Really, the missing link is in between the customer and the supplier. So under a CCA, you have a number of different vendors, in some cases many vendors. That will be power suppliers, a transmission scheduler, back office functions, that's your conventional CCA. But CCA 2.0 also will include distributed generation operators, demand response operators, automation, electric vehicles, dynamic chargers, all these many pieces that have to be deployed in parallel and become interoperable as a single architecture on a single network. So you need an integrator that's going to put those pieces together. And part of the challenge is that we tend to think that the integrator should always be a vendor. Why? Because we think it's the market players that are innovative and they're the ones who have to deal with complexity and put the pieces together. But that's a problem because CCAs are local democratic entities that are locally governed. They're under state requirements that give them powers the private sector doesn't have, such as full unlimited access to utility and use meter data. That meter data, in many cases 15-minute reports on hundreds of thousands, if not millions of meters, is critical data for knowing what's happening on the grid, what's happening in every home and business, what is the history of what normally happens in those homes and businesses. Local governments that form CCAs are also repositories of other forms of data, and they are the managers of that data, such as zoning data, land use data, infrastructure data, etc. They're often partnered with federal agencies that have confidential data, such as the transmission system, conditions at substations. These layers are all part of the pie, or really the cake, that constitutes a CCA 2.0, and they have to be integrated into a single brain, a single intelligence. That intelligence, because of the structure of CCA, actually needs to be in the CCA itself. It can use contractors to do its work, analytical work, but it can't just depend on market players to make decisions about what technologies should be inserted where, or how they should function in real time. In order to know that, a great deal of analysis needs to be done, operational systems need to be created, monitoring and control systems have to be established, databases have to be integrated, and those have to be all combined into a single intelligence. And that's part of the challenge of CCA 2.0, is you can't just contract things out in a simple kind of way to the private sector and just have it add up, because it will add up to a large pile of garbage. But if there is an integration that uses that full access to the data, then you have quite the opposite, an ordered, rational system that provides benefits to the grid, that reduces the cost of energy to the whole community based on reduced capacity charges and capacity factors, on peak shaving and peak load management, on real-time demand dispatch. Those integrations cause these technologies to provide savings and therefore to make the technologies cost-effective, to lower costs rather than increasing costs, and therefore to expand the horizon of what is achievable by those networks and the degree to which customers are engaged to want to purchase the products that are embedded in those systems.